Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, number 35 of NEET Physics paper 2015. Let us solve number 35. A conducting square frame of side A, this is a square frame whose side is A, and a long straight wire carrying current I, this would be I, carrying current I here, as shown here, are located in the same plane as shown in figure. So this frame and this wire are lying in the same plane. The frame moves to the right with a speed constant velocity v. This is moving with a constant velocity v. The EMF induced in the frame will be proportional to. First of all, if this is the wire which carries the current I, and there exists a frame, square frame of side A, this side is A, this side is A and A because square frame. So it's a square frame. Now we have to find the EMF induced in the frame, and this is moving with a velocity, constant velocity v. How far it is from this center? It is x. So it is given in the question that this distance is x. So from the wire to this bisection, midpoint of this frame, the distance is x. Now if this is x, we know that this distance is a, so this distance will be a by 2. So this distance will be a by 2, this one, and this distance is also a by 2. For this part of the frame, the EMF that is induced EMF is given by induced EMF is given by E equals to BLV. This is the induced EMF developed in a conductor moving in a magnetic field, conductor of length L moving in a magnetic field of say B, BLV. Now QVB, B cross B. So this is how this cross B is why this magnetic field is produced. This magnetic field is produced due to this wire, because this is the wire and current is in this direction, so magnetic field will be like this, concentric circles. So from this side it is up and this side is down. So this side is up and this side is down. So therefore, due to this, the magnetic field will be down here, down here. But the magnetic field here is different. Suppose it is B1, and this side it is suppose B2, because that varies with the distance. We know that the magnetic field B due to a current carrying wire at a distance is given by mu0 upon 4 pi 2I, whatever is current that carries, divided by the distance x. So B is inversely proportional to this distance x, or this distance x, or I will write, because x I am using here, not to get confused, I will write 2I divided by r. So B is inversely proportional to r is the point or from the wire. R is the point from the wire, the distance. from the wire where we want to find the magnetic field. So here this BLV sine theta, but in this case here the velocity is v, here also the velocity is v, this will also be moving with v. When length is perpendicular to the velocity, then in that case the formula used is BLV, and in this case suppose the potential difference created in this, the EMF induced in this part of the wire is E1 and in this part of the wire is E2, and then both are in the same direction, V cross B. V is like this, B is into, so this side is positive. So I'll just write for the convenience, this is positive, this is negative. How this induced EMF is generated here. So this is positive, this is negative, this is E2. So this is a frame which contains, as if it contains two batteries, and their EMFs are in the, they try to send current in the same sense as is seen here. The positive terminals are connected together, so they will cancel, the net EMF will be cancelled. So in this frame, in this side, in these two sides there is no EMF induced, because this part of the conductor is moving parallel to the velocity. The length is parallel to velocity, so when the length is parallel to velocity there is no induced EMF. So here the induced EMF in the frame, the induced EMF is given by E of the frame is basically E1 minus E2. Why it is E1 minus E2? Because this is more nearer, as you can see that B is inversely proportional to R. The smaller R, greater B, so greater B is greater E, so therefore E1 minus E2. This will have a battery of higher EMF than this one, so the difference is the EMF induced in the wire, and finally the current will flow like that. So what is E? Because we know that E is equal to BLV, so in this first case it is B1LV. In the second case it is B2LV, because V is same and L is same for both the conductors. So if I substitute that, then this is B1LV minus B2LV. So it is B1 minus B2LV. Now B1 minus B2, I will just write that B1 is how much? LV. What is B1? B1 is mu 0 upon 4 pi 2I divided by X, here R, and this distance you write. This is the distance that are used for this, and suppose this is x1 and this distance is suppose x2, so I write here x1 for B1. And how much is this distance? How much is this distance? This total distance is x, and I'll subtract this a by 2, so this will I'll get x1, so mu 0 upon 4 pi 2I by x minus a by 2. This is similarly about B2. So B2 is mu 0 upon 4 pi 2I divided by x plus a by 2, because B2, this distance is x distance plus this distance which is a by 2, so x plus a by 2 here. If I substitute that, then mu 0 upon 4 pi 2I will take common, LV is also there, LV will common, then inside it is 1 over x minus a by 2 minus 1 over x plus a by 2. If I rewrite that equation, induced EMF in the frame equals to mu 0 upon 4 pi 2I LV, bracket starts 1 divided by 1 minus a by 2 1 divided by x minus x plus a by 2. If I solve this, then mu 0 upon 4 pi 2I LV, this if I take 2 minus, so if I take here 2x minus a, here also 2x plus a, 2 will go up, so 2 common out, one more 2 will come out, and here it is 1 divided by 2x minus a minus 1 divided by 2x plus a. So this is mu 0, 4 will cancel, divided by pi, and ILV into, this will be 2x plus a minus 2x plus a, because minus of this is because minus of this becomes plus a, divided by 2x minus a into 2x plus a. So this will cancel out, and this 2a is there, so mu 0 upon pi 2a from here, ILV from here, into 1 over 2x minus a and 2x plus a. Now E frame comes out to be this. The question is, the E frame means induced EMF. Induced in the frame is proportional to, you can see here, this is proportional to, these are constants, it's proportional to this value. That means from here I'll write that E frame is proportional to 1 divided by this 2x minus a and 2x plus a. This one is proportional to, because this is a constant, so this is proportional to this one. So if I see the option, then is proportional to 2x minus a, 2x plus a here, 2x minus a, 2x plus here, reciprocal, so it is inversely proportional to this. So therefore option number 2 is the right answer to question number 35. Okay, thank you.